In this lecture, we discuss two concepts, random variables and expectation. So let's start with the distribution of random variables. A random variable is a rule that assigns to each outcome some number. For example, if we are tossing a coin 3 times, the first time we may get head or tail, the second time head tail, the third time head tail, so the sample space S consists of head, 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 tail. Those are all possible outcomes. I'm trying to list them here. Head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. We have 8 outcomes because number of outcomes of the first stage is, or first toss is 2. Number of outcomes of the second toss is 2. Number of outcomes of the third toss is 2 because we only have head or tail, and using the counting principle we just multiply these number of choices of each stage, so we get 8. That means we have 8 outcomes here in the sample space. Okay, now let x denote, x is a variable, x capital letter here, it's a variable that denotes number of heads that occur in 3 tosses. So x represents number of heads that occur in 3 tosses. So we may get no heads, all of them are tails as we have here, or 1 head, or 2 heads, or maximum 3 heads. So these are the values that we are talking about. So for example, 0 is assigned to the outcomes, the outcome tail, tail, tail. 1 is assigned to the outcomes where head appears just once. So head, tail, 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 head, tail, or tail, tail, head. 2 denotes the number of, or means 2 heads can occur. And that means we have head, head, tail, head, tail, head, and tail, head, head. 3, x, the value of the random variable is 3. That means the head appears 3 times, and that occurs just once. Now these numbers are denoted by little x. So this is x1, little x2, this is x3, this is x4. And in general, the random variable is denoted as x capital letter or y capital letter. So this is a random variable. So it assigns to each outcome some number. Now let's take another example. A coin is tossed repeatedly until a head occurs. Let x denotes, or let x be the number of coin tosses in the experiment the question is, what are the values of the random variable x? Now here, what is the sample space? The sample space is, now we are tossing a coin until first head appears. We may get a head from the first toss. We may get head in the second toss. We may get head in the third toss. We may get head in the fourth toss, and so on. So this is infinite we have infinite number of outcomes. So this is infinite number of outcomes. And since we have infinite number of outcomes, we can define now x, the random variable, to be just from the first toss we get that head, from the second toss, from the third toss, from the fourth, from the fifth, etc. So this is the random variable. This is the random variable. And these are the values of that random variable. This is called infinite random variable. And actually, since the random variable consists of 1, 2, 3, and we don't have any number between 1 and 2, we don't have any number between 2 and 3, 3 and 4, and so on. So this is actually called discrete random variable. Discrete, that means it occurs at some points. I mean, when x is 1, when x is 2, when x is 3, at specific values. It cannot occur all the time. If we are talking about totals of students in some class, the totals can accept fractions. So it can be any value. For example, between, if we are talking about meters, between 0, any value between 0 and let's say 3 meters. This is just an example. So that means it accepts fractions. But here, the discrete random variable does not accept fractions. Another example, let x be the length of the life of a battery. Here, in this case, the random variable x takes values from 0 to infinity. So it's infinite, and not only infinite, it's continuous. Continuous because that value can be anything between 0 and infinity, and it can be fraction, that's okay, or a natural number. Another example. Now, if we want to find the probability, find a probability distribution of the random variable associated with the experiment of tossing a coin, let's say 3 times, and observing number of heads that occur. Okay, now here the question is about probability distribution. What do we mean by probability distribution? By probability distribution, we mean a table that consists of a value of a random variable and the probability of that variable. This table is called probability distribution, but we have some conditions on this. So let's start counting number of heads in 3 tosses. We may get 0 head, or 1 head, or 2 heads, or 3 heads. What is the probability of getting 0 head? 0 head, that means tail, tail, tail. So how many tail, tail, tail appear? Just 1 out of 8. So it's 1/8. Head appears once. We have 3 out of 8. Head appears twice. Twice, it's 3 out of 8. and head appears 3 times, just one outcome of 8 outcomes. Now this is probability distribution if the sum, we have some conditions, if the sum of the probabilities is equal to 1. So we have 2 conditions. First, let's start with the second. The second is the sum of probabilities is 1. For example, we have 1/8 plus 3/8 plus 3/8 plus 1/8. If we add the numerators, we get 8, and the denominator is 8, that's 1. So the second condition is satisfied. The first condition is that each probability should be less than or equal to 1, from 0 to 1. Or we just write less than 1. It's well known that it's known that the probability is greater than 0, greater than or equal to 0. So probability is less than 1. As we can see, the first probability is 1/8. It's less than 1 because the numerator is less than denominator. The second one, third one, and fourth one. So the 2 conditions are satisfied. That means this is probability distribution. Now, if we ask for the same problem, if we want to find the probability of obtaining at least 2 hits, at least 2 hits, what does that mean? That means we want to find the probability, we write it this way, probability of the random variable greater than, at least that means greater than or equal, greater than or equal 2 hits. We write it this way. This is number of hits. So we want number of hits to be greater than or equal to 2, because the word at least, that means greater than or equal to. Now this is equal to probability of x equals 2 plus probability of x equals 3, and that's it. Now what is the probability of x equals 2? Probability of x equals 2 is 3/8, and probability of x equals 3 is 1/8. This is 4/8, which is 1/2 or 0.5. Now another example. Let x denote the random variable, let me write it as abbreviation, RV, random variable, that gives the sum of the faces that fall uppermost when 2 fair dice are rolled. The first question, find the probability distribution of the random variable x. So to find this, we make a table. This is x, little x, and this is the probability of that little x. Now it's tossed twice, and the sum is, we observe the sum. The sum can be, if we get 1 on the first die and the 1 on the second die, we get the sum of 2. Then we have sum of 3, sum of 4, up to 12 if we get 6 on the first one and 6 on the second one. Now what is the probabilities? To get 2, we only have one outcome, which is 1 on the first die and 1 on the second die. That means just one outcome, 1, 1. So it's 1 out of 36. Okay. Now what about x equals 3? That means the sum is 3. Sum is 3 is either 1 and 2 or 2 and 1. So those are 2 outcomes out of 36. Now sum is 4 is 1, 3, 3, 4, 3, 1, 2, 2. So we have 3 outcomes out of 36. It's out of 36 because the first die has 6 faces, and the second one also has 6 faces. So 6 times 6 is 36. That's number of outcomes of the sample space. So we divide by that number, and so on. 12 with 12, we just have one case when we have 6, 6, and that's 1 out of 36. You can complete this table. This is the distribution, the probability distribution, because the sum of the probabilities is equal to 1 if you try it to exhaust or to list all the probabilities and the corresponding random variable values. And as you can see, each probability is less than or equal to 1. Now for part B, we want to find the probability that the sum of the faces that fall uppermost is less than or equal to 5. Now this is the probability we want to find. Probability of less than or equal, the value of the random variable is less than or equal 5. So that means probability of x is equal to 5 plus probability of x is equal to 4 plus probability of the sum, which represented by x, is equal to 3 plus probability of x is equal to 2, and that's the minimum. We don't have probability of x equals 1. The sum should be, the smallest sum is 2. Now probability of, we find these probabilities. Now probability of x equals 5 is, we have for 5 1 4 4 1 2 3 3 2. So we have 4 outcomes. So 4 out of 36 plus x equals 4. We computed this. It's 3 out of 36, and then x equals 3, 2 out of 36, and x equals 1 is 1 out of 36. And for this problem, if we start with 4 over 36, then the next one is smaller, then we reduce by 1 the numerator, and then we get the sum. It's 10 over 36, which is 5 over 18. Another problem. The following data, if we have this data, we have cars, number of cars, and the frequency. Here the problem, this gives number of cars observed in a line, number of cars observed in a line at the beginning of 2-minute interval between 3 p.m. and 5 p.m. on some day at the drive-in teller of a bank. And the frequency of occurrence. So we have these values. 0, number of cars, 0 is 2 minutes, or frequency is 2, and 1 corresponds to 9, 2 corresponds to 10, 3 corresponds to 16, 4 corresponds to 8. Now we want to find probability distribution of the random variable capital X, where X represents number of cars observed waiting in line. So we make a table with X represents number of cars 0, 1, 2, 3, and 4. And the probabilities, the first probability is 2 out of how many? 2 out of 45. the number of frequencies, 2 out of 45, and this is 9 over 45, this is 10 over 45, this is 16 over 45, and this is 8 over 45. We can check if this is probability distribution. Part B, we want to know what is the probability that number of cars observed waiting in a 2 minutes intervals between 3 p.m. to 5 p.m. Is less than or equal to 3. So here we apply the probability of x, the value of the random variable is less than or equal to 3. That means probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2 plus probability of x equals 3. Now we find these probabilities. Probability of x equals 0 is 2 over 45, x equals 1, 9 over 45, x equals 3, 10 over 45, x equals 4, 16 over 45, and this is 37 over 45, which is 0.8222, etc. Now the second part of this lecture is the expected value. So this is 8.2, the expected value of a random variable. So what do we mean by expected value? Let's start with the mean. What do we mean by a mean? The mean is the same as average, and this is the average value of a set of numbers. For example, if we have the set of numbers 2, 7, 1, and 10, then the mean denoted as x bar is equal to the sum of these values divided by the number of these values, which is 4, and this is equal to 5. Now we use this notation. X bar is the mean, is equal to the sum. This is sigma notation. This means sum of xi, each value of the random variable. This is x1, this is x2, this is x3, this is x4. So this, we denote these as x sub I over all over n. N is number of outcomes. How many value are there? 4. N is 4, and I is from 1 to 4. So we find the sum of these values from 1 to 4. This is just a notation, and this is the explanation of this notation. Let's start with the following example of tabular data. So we find the average number of cars for the previous example waiting in a line at a bank at the beginning of each two-minute interval during the period, but I can give you the data here. We have number of cars and frequency. So number of cars 0, 1, 2, 3, 4, 5. I'm gonna add more values, 6, 7, and 8, and the frequencies are 2, 9, 16, 12, 8, 6, 4, to 1. Now we can denote number of cars by X and frequencies by F. Now, so this is tabular data, so we need to consider frequencies because each value of these occur in some frequency. So we want to find the average. We want to find the average. The average in this case is not only the sum of these values. It's the sum. We have each value has some frequency. So we need to multiply each value X by its frequency and then divide by n. And we take the sum. So we have 0 times its frequency plus 1 times its frequency plus 2 times the frequency plus 3 times the frequency plus 4 times the frequency plus 5 times 6 plus 6 times 4 plus 7 times 2 plus 8 times 1. All this divided by how many values are there, or the sum of the frequencies. What is the sum of the frequencies? N is equal to 60. So we divide by 60. We get, using calculator, a number that can be approximated by 3.1. This is the average. Now what is the expected value? Expected value, this is actually this average is also served as expected value. So the expected value for the same problem, we can write these values, I mean the answer here, in this form. We can write it as 0, which is X, times 2 out of, we divided by 60, plus 1 times 9 over 60. I just rewrote this in another way because this is 1 times 9 all divided by 60, so it's the same as 1 times 9 over 60 plus 2 times 16 over 60, and we continue until we get 8 times 1 over 60. And if we look at these, we find that this number here denotes probability. Let's call this probability 1, and this is a value of the random variable. Let's call it x1. This is x2, and this is its probability. This is x3, this is its probability, and so on. And we have sums here. So this is called expectation. This is expectation of the random variable x. So in order to find the expectation, we multiply x, the value of the random variable, by its probability. So expectation of x is the sum of x times its probability. Let's take an example. If we want to find the expected value of the random variable x that denotes the occurrence or occurrence rate at a hotel. So we have the following table. We have the occurrence rate and we have probability. So here we have 0.80, 0.85, 0.90, 0.95, and 1, and the probabilities are 0.19, 0.22, 0.31, 0.23, and 0.05. Now we want to find the expected value. So we are asked to find expected value. What is the expected value? Now let's denote this as x and the probability by p. So we multiply each x by its probability and add it to the next product of the value and the value of the random variable by its probability until we finish the table. So we have expectation of the random variable x is 0.80 times its probability. So this is x1 times its probability. x1, this is probability 1, x2, probability 2, and so on. x3 probability 3, x4 probability 4, x5 probability 5. Now we add 0.85 times its probability plus 0.90 times its probability plus 0.95 times 0.23 plus 1 times 0.05, and if we use the calculator we get 0.886 or 65.